Hello everyone. So today I will discuss about the very simple question, but this question is very important in the next questions which we will discuss. All right. So this is kind of basic question you can say, which will be useful in lot of other question, and how we are calculating the height of the tree. That is more important than the question. Right. The approach which we will follow, the same approach we can use in the different kind of problems as well. All right. So first question is, hey, what is the height of the binary tree? Height of the binary tree is nothing but, in simple terms, I can explain you a maximum number of nodes in any path from root to leaf node. What it means, okay? Let's say there is one path from root number 1 to leaf 4. 1, 2, and 4, you can see, okay? How many nodes are there in this path? 3 nodes are there. Now, second path is nothing but 1, 2, and 5. How many nodes we have? We have 3 nodes again. Similarly, you have 1, 3, 6, and 1, 3, 7. So we have total 4 different paths from root to leaf. Now you need to calculate the number of node in each path. So here all path have 3 nodes. Now take the maximum of these nodes. So here we have maximum is also 3. So height of this binary tree is nothing but 3. All right. So very simple. What is the height? Height of the binary tree is nothing but the maximum length of a root to any of the leaf node is known as the height of the binary tree. Right. Now, okay, this is the simple question which we can do. How to do the programming? How to write down the code just to get the height of the binary tree. So the way we have understood it, okay, we can do the same thing. You will start counting the length of root to leaf, and once you reach to the leaf node, just take the maximum of that, right? This way we can do. And can we make it simple? So instead of that, can we make it simple? Yeah, we can make it simple. And that is how we can do is, let me explain you 1 second. So what we will do, okay, we'll start from the bottom. Okay, we will not start from the top, we'll start from the bottom side first of all. And what it means is, you will start from the bottom. From point number 4 you will start. Okay, now you will say, hey, how you are coming to the last leaf node, okay, without reversing? Yeah, we need to traverse it, but the logic which I am explaining is that logic will work from bottom to up. So for each node, what you need to do, you need to return 2 values. You just need to return 1 value, which is 1 plus maximum of left height and the right height. Now, what is the left height? Left height for each node is the maximum, is the height of the left subtree. Okay, so in this case, 4 left side of 4 doesn't have any node, so height is nothing but simply 0. Similarly, right of 4 is also 0, right? Now this 4 will return to the 2. It will return this formula, 1 plus maximum of these 2. So 1 plus 0, right? Because maximum of 0 and 0 is nothing but 0. So it will return 1 to the node number 2. All right, that is fine. Similarly, we will calculate for the 5. 5 left height is nothing but 0, right height is also 0. It will also return 1 plus maximum of these 2, which is again 1. All right. Now, what this 2 will return to 1? It will return maximum of this 1 and this 1 plus 1. So it will return 2. Understood? So for every node, you need to return 2 things. 1 plus maximum of left height and the right height. This way we will keep returning up to the top. Now, if you will apply the same logic in the right side also, you will get 2 from 3. All right. So you will get 2 from here. Now what this 1 will return? This 1 will return 1 plus maximum of left and right, which is nothing but 2. Right. So we have here height of the binary tree is nothing but 3. Right. From this formula, we can see that we are able to get the height of the binary tree, which is nothing but 3. The same thing we were achieving with the help of this technique also. You just calculating the path, and we were calculating the number of node in each path, right? So don't you think this approach is looking better? And this is working different way. So same problem we can solve two way we have, okay? First one is also very important, because that we will use in lot of questions. When you will go for the interview, sometimes you will get the question like, hey, give me the path whose sum will be equal to this number, right? That time what approach you will follow? That time we will follow this approach. We need to traverse all the path, and we will calculate the sum of each node in that path. Once we reach to the leaf node, if the sum is equal to the path sum, it means we got the path whose sum is same as the given sum. So this is very important technique actually. Okay. Now, this is also very important part, that in most of the tree questions, we won't be able to start from top always. We need to figure out a logic which will start from the bottom side to the top we will come. All right. So do not worry about that. Let me quickly explain the coding of this question. So I have one tree is same 1 2 3 4 5 6 7. This is the same tree which I am using 1 2 3 4 5 6 7. Now I want to calculate the height of the tree. Okay, you just need to write one method height and just pass the root as the parameter in that. So here you can see we are passing a root to the height. Okay, now what is the first condition? Because we are writing the recursive solution just to reach to the bottom of the tree. So in every recursion, base case is very, very important. So you can keep one thing in mind for all the recursion. This condition will always be there. If root is null, please return from here. Don't do anything, right? So root null means height is also 0, right? Now what we will do, we will call the same method just to get the left height of the, left height, and we will pass the root dot left as the parameter. Similarly, we want to calculate the right height by passing the root dot right. Once we got left height and right height for this root, okay, what you need to do, you just need to return 1 plus maximum of left height and the right height. So this formula you can see we are doing this thing, right? So very simple. If you will run this piece of code, what you will see, you will get the output height of the binary tree is nothing but 3. Let me quickly modify it. Okay, so let me, after the node 7, let me apply one more child. So node 7 dot left has one node, let's say 8, whose value is 8. Now what it means, that here I have applied one more node in the left side of 7, so height should be 4 this time. Okay, so let me just run it. We can verify it. We got the height as 4. All right, so this is how we can build the logic, and this is how we can calculate the height of the binary tree. I hope it is clear. If something is not clear, you feel something is not clear, please comment out, and I will be happy to help you in the future videos. So please stay tuned for the future video, and thank you everyone. If you like my content, please like, share, subscribe. Thank you. Bye everyone.